I feel like that's me sometimes when I'm not using my task management tools properly. I really like the simplicity of Taskwarrior because it allows me to not have to leave my dev environment or terminal, but I can still keep track of what my tasks are that day. I was looking at just the options for extending the visual appeal of Taskwarrior because, of course, I work for a glamorous command line company and, of course, I want to glamorize it, okay? But Taskwarrior is not built with Go, which means that I can't use my Go libraries that I would love to have beautifully formatted, stylized outputs. So instead, I decided to reinvent the wheel and just copy it in Go. And now I'm going to show you how you can do that so that you can learn how to build a task management tool, a Taskwarrior clone, in Golang. We're using Cobra and we're using lip gloss for some stylized outputs. And the nice thing here is, so we are gonna have a table view and a Kanban view. Sounds familiar, doesn't it? But you can also feel free to extend that and demonstrate your tasks in any kind of layout or styles that you want now that we're in the Go ecosystem and you've got the power of lip gloss behind you. So we've got a bit of a checklist here, and it's a little bit of a different style because I'm not going to be coding along with you, but I am going to show you the solutions to each of these milestones. So the first goal is that we're just going to get set up with our data storage. So we're going to learn how to do a SQLite database, how to open the database, add information to our DB. So that's the basic kind of CRUD operations that we're going to do with a SQLite database. And then the next stage is that we're going to make it interactive with CLI. So users are going to be able to have commands and subcommands for working with the tool. And we're going to be using Cobra for creating that CLI, and it's just going to basically make it all of our CRUD operations accessible with commands and subcommands. And then to add a little chef's kiss to the final product here, we are going to print to a table layout and we are going to print to a Kanban layout that's a little interactive. Each of these files is going to have the solutions that you need for each of the steps along the way here. Now that you've got kind of the skeleton of the project, I'd rather you try and solve each of the steps yourself and then come to the video to look at the solution and understand how and why it works. So that's kind of my vision for this style of video. But of course, just let me know what you think, because it's kind of the whole point is that you're here hanging out and watching it. We're gonna open our main.go file, and this is where we're doing some of our initial setup for our application. That includes getting the path set up for where we're gonna be storing our SQLite database. That's what this setupPath function is doing here. So this one is XDG-compliant. It uses Go app paths, which is built by our very own Muesli, that queries both app and platform specific paths, and that's what gets returned. You read in what the paths are to those data directories, and then from here we check if there's more than one directory. Let's take the highest priority directory and assign that to our task directory. That's where we're going to write our SQLite database. If not, let's just grab the home directory and assign that to our taskDir, where we're eventually going to write our database. So in this one, we're doing initTaskDir, and we are in the db.go, by the way, so you know. For the record, I could probably move this to the main.go so that it's all kind of together. I don't know why this one's over here. I'm just a chaotic programmer, apparently. So initTaskDir. This one receives a path, and basically we just check if a file or folder exists there already. If it doesn't, then we're going to create it and make sure it has the right privileges so that we can write to it when we're interacting with our application. So then if that causes an error, then we're gonna, fail the application because we can't write to the system. We don't have anywhere to save the database, so basically we crash and burn. Each time that we're doing some kind of database operation, it's getting called when we also trigger to open the database. This OpenDB does exactly what it says it does. It opens a SQLite database, and I've provided it with a path to the database file. We create a tasks.db file within that directory. And then here we create a new taskDB struct, which holds our SQL database and our data directory. So it's like our path. And then we just do a quick check to see, does our tasks table exist already, so that we're not overwriting anything or like causing any conflicts or getting a SQL error in case we're trying to write to a table that doesn't exist. Basically, this is opening the SQLite database. So we can check that off the list. And then let's kind of ignore what's going on in the main file right now with the root command. We're not there yet. What we can do is go to our db.go file, and this is where we're doing the bulk of our work for that first section of the data storage. So here we've just got a helper that is converting our iota, aka go enum, to string values. That gets used at some point. And then here we have our task struct, and this just has all of the fields that we want in our SQLite database. This is so that we can display it in the Kanban board. Okay, so we've got the filter value, and we've got title, and we've got description. So those are just implementing the list.item and list.default items that you need to implement for any of your own custom list items. And then here we're implementing the Kanban CLI, the other library that we're using for the Kanban board. This is its status interface. So when you hit enter, you know how it moves from one column to the next? That's all that this is doing, is it's just kind of letting you do that. All right, and then here we've got our taskDB, which is just our data layer structure, and that holds our database and our data dir. So here we're initializing the taskDir, which you saw already in our main, and that should probably exist in the main function just so that it's with whatever is calling it, right? It's only really being called in that main function. And then we're doing our table exists. And then we've got a create table, which is just a SQL command for creating a new tasks table. And this is using all of the fields that we have in our custom task struct that we want to exist in our SQLite database. And it sets our ID to auto increment. And then with our insert, I've left some little notes here. We don't care about the return values, so we're using exec. If we wanted to reuse these statements, it would be more efficient to use prepared statements, and you can learn more about that in the link there. And so here we're doing t.db.exec, and we are just inserting into tasks. And Muesli mentioned that if you are doing any kind of SQL queries and stuff like that, that it is best practice to keep the SQL keywords as all uppercase, even if you don't need to in Go for it to work properly. He said it's just a good practice, so worth noting that. And another important thing is the way that this query is structured. So I am using parameterized SQL statements, and you'll see that throughout this entire tutorial here, that we're using the parameterized SQL statements to avoid SQL injections. Make sure you're doing that, okay? Only use your parameterized SQL statements. For insert, we're going to set a name project to do.string and time.now. We're just going to make it happen at the current time. And then here, just a basic SQL query where we're just going to delete it where the ID matches. And what's great about this is that this code is actually it's very simple, it's very testable. So I actually did include a test file in case you're hoping to write some tests along the way. If you want to do some test-driven development or just practice writing your tests along the way, this was pretty straightforward to do for the data layer. So all of the like insert, delete, all of the CRUD operations, I made sure to write tests for just in case, just to make sure that, you know, everything's working as it should before adding the CLI layer. So if you want to understand how some of that stuff's working under the hood and what the setup and teardown and all of that looks like for the tests, I can go over that after I finish the db.go file. I think tests are really fun for just trying to understand how something works. You know what I mean? So if you're looking at a piece of code and you're like, but how, what? You know what I mean? And you just look at the test. So in this update function, it allows us to just provide multiple changes to make to any given task. And how it does that is that it receives the new task as a parameter, and then it will query the database for whatever the task used to be, the original value, and then it'll merge the new task to check which fields have changed and which ones haven't. And it'll set those new values in the database. And we can check out with that merge function, how that actually works. So this is why we had to have exported fields in our custom task is because this merge is checking over all of the fields in each of these tasks and comparing them to see if it's changed. And reflect will only work on exported struct fields. And then here what's going on is we're basically grabbing the LM. Okay, so that's basically, it's just the value, the reflect value of a task. All right. And then here we're iterating over all of the fields in the new struct. Like, it doesn't matter. We could have done this O values or U values. They both have the same number of fields, so it's fine. But we're iterating over the fields, and then we are checking the field. This is the current value as an interface, because, you know, generics, crazy, Golang, like whatever data type that is, are we able to set that value on the original task? And if you can, this is checking the type of the field. So we're doing a type check. Okay, is it an int? Yes or no? If it is an int and it is set, then let's change the value of whatever field we're on for the original task. And then it's doing the same thing here for the string. So it's just doing a type check on whatever field we're currently iterating on. In the updated task, it's checking, okay, has that been set? And if it has, then update whatever value that same field has in the original task. Okay. We're using a pointer for the orig value for both of these tasks when they're being set, because if we're setting either of these values when we're doing reflect.value of, this has to be a pointer. Clear as mud? Perfect. All right, and then we do our getTasks, which is just select everything from tasks. It's basically just iterating over the rows that get returned from our query, and then setting those values to a task struct, and then appending that to our list of tasks. And then finally at the end, it returns that list of tasks. This just allows you to query all of the tasks that have a certain status. Right now it's only being used, I think, in the Kanban commands. Yeah, so it's only being used with the Kanban board, but you could totally change that to also be a filtering option for your regular list output, as well as like as a flag or something. There's a little piece of homework if you decide that you want to extend this a little bit more. And we're just doing something very similar. We're just iterating over the results that we get back, assigning that to a task, appending it, and returning that list of tasks. And then this one, we are doing a query row because we know that it's only going to be getting one value back. We're scanning that into a task variable that we initialized at the beginning of the function, and then returning that variable. And that's it. That is all of our data storage stuff that we wanted to do. We've got our opening our database, which is in the main.go file. The rest of it is all in this db.go file. And now let's get into the tests. So I'm going to show you how you can write some tests here. So here I've got my TestDelete function. I did a table-driven test, even though I've only got one test case. Okay, don't at me. I personally just like the table-driven tests because then I can just add more and I don't have to fully refactor the whole test. I like to use t.run because it allows you to kind of have a name associated with the test case that you're running. So when the test fails, it's a lot easier to figure out where it failed and then debug from there. And then for each test case, which is what we're doing here, we're iterating over the list of tests, and we are doing a setup and teardown for each of these tests. I think in this case, I would have been better off doing the t.tempter and writing my database in there. So if you want to write an enhancement of that, there you go. Got you. I got you. I'll keep giving you more things to do. Don't worry. Don't worry. I can write bugs all day. So we're just doing our setup, which I guess I can show you how that works. I'm just doing a clean tempter, which is just a tempter from the OS package. Oh yeah, and this one was so annoying because there was a bug between Mac OS and Linux where like one of them didn't include a slash at the end. So I got to double check whether the last element in the list is a slash. Otherwise you need to add a slash so that it doesn't cause an issue. So yeah, so that's what we're doing. We're just opening up a new SQL database, creating a new TaskDB, and then that's the TaskDB that is getting used in our test. And then in our teardown here, we close the database and then we remove the data directory. And then here we are testing our insert and our delete, because how are we gonna delete something if it doesn't exist? All right, actually that would be a good test case as well. That's a good edge case, is like, what if you try and delete something that doesn't exist? Okay, what's it gonna do? Make sure that you account for that, which I did not. So if you wanna write another test, you wanna get a little coding in, there you go, write one of my test cases where it doesn't insert anything. So in this case, I'm just like, all right, I'll see what happens if it's a fresh database with only one value and I try and delete that. So that's what we're pretty much doing here. We're doing an insert, we're getting our tasks, and I hard-coded the first task index here because I'm a risky girl, risking it all for the tests. And so here I'm just doing a reflect.deep equal to compare the two structs and make sure that they both are what we want them to be. You know what I mean? You know what I'm saying? And then we delete it and just double check that we didn't get any unexpected errors. And if the length of the tasks is not empty, then we're gonna have a problem. So again, in this case, funny that I did a table-driven test, because this test is very much tailored to the expecting that there's only one value that is being added to the database. And then we test getTasks. So this one's similar. It's got the similar setup, teardown, and we're just writing tests for all of our getters, making sure we don't get any unexpected errors, doing our reflect.deep equal to compare two structs. And then there's this update, which is just testing that the only thing that's changing in the new is that the name is changing. So what's happening here is the old is going to get added to our database, and then we are going to update with the new task. And then we're just going to double check that the other fields, that it got merged properly, right? So that the name is what's changed, the project and the status stay the same. And then I've also got a test for TestMerge, because I was writing the test while writing the code for merge to make sure that it was actually working as expected, which we love. This is just comparing like the same thing, two tasks, making sure that the structs are equal. Whereas the other one is also querying. It also has a database included in the test, just to make sure it's writing to the database properly as well, right? Gotta make sure my SQL queries are working, you know? And then the getTasksByStatus, blah, blah, blah. I think we've gone through all of it. Let's get into the next part, which is building the actual CLI that the user is going to be able to interact with. All of that is housed in the commands file. So we'll open up our commands.go, and you'll see here with Cobra, there's always a root command that gets triggered. And now we can actually revisit what we looked at in the main file. So here you'll see that pretty much any time that the binary gets executed, the root command gets executed. This is what gets run when you just call the binary itself. So root command, here I just have it returning the help. Got the add command here. And as you can see, this use and short, these both get used to generate the help. So Cobra is auto-generating that command.help. That is built in, and it's based off of the use and the short descriptions that you give your commands. And that's how the users are gonna know what commands you have for your application and how many arguments they need and all of that stuff. So you see here that basically we're just using the insert. We're just using the insert. We're seeing if they used a project flag. If they did, then we're also gonna insert the project name into the task. And that's pretty much it. We're just writing to our database. And what's nice about this is, like, you don't really necessarily want to be testing these commands, right? Because they're just subcommands that do something. So this runE, this can also just be a function that you define separately. It doesn't have to be an anonymous function. And you can write a test for that function if you decide that you want to. In this case, I've already got all my edge cases tested here. And then we've also got the delete command. So this one, similar thing, you kind of just give it an ID. I should also be letting them know that they Need to add an ID there. And this is the same thing. We're basically just doing our DB setup. We're just grabbing the argument that gets given to the delete command, which is an integer. So we receive it as a string. We have to convert it to an integer, assign that to ID, use our delete command or our delete function that we previously defined. So for our update command, we're just doing the same kind of setup that we did previously, opening the database, deferring the close. We're grabbing all of the information from the flags, which include the name, project, and status to see if any of those have changed from the command. And then we're grabbing our ID from the list of arguments. And then one thing that might stand out to you is that this flag for status is actually an integer. I decided to do that just so that it minimizes confusion for the user. It's basically going to be the index of the column that you want it to go to. So it would be like to do would be 0, in progress 1, done 2. I was just thinking if it's a string, it's like then you got to handle like it being case sensitive, then you got to handle like the input being an invalid input, and it can just be a little more fussy. If you disagree with me, feel free to let me know, and I'll reconsider the design decision there. But for now, I decided to just keep it as an integer if you want to update your status, just for simplicity's sake. But when it is being stored in the database, we are storing it as the string. So it's basically grabbing the string values from our enum, or iota. I ought to not say enum. So we're creating a new task, and then we're updating with the new task. This list command, I decided to keep it similar to the Taskwarrior, where it's just a table, but I didn't want to design a table. Okay, I didn't want to do that. What we're doing here, we're gonna speed past the open DB, close DB, all that good stuff. And you're gonna see I'm setting up a table. I have another function here. So what's going on here is that I'm actually using one of our bubbles components, but I'm not using any of the interactivity. I'm just using the layout. So I'm just using the view, which means that I'm just gonna get back a string value, and I'm gonna print that. That is me using the styling from one of our bubbles components and just putting in my own values there and just printing it out. If you want to add interactivity, you can go for it. We're going to see that a little bit more with the Kanban board. But for now, we're just going to render a static table that has all of the information that we want in there. So I'm defining the columns here. With the table.column, this is going to have each of the fields that I have defined in our database. We're creating rows for the table. We're going through and appending one row for each task. The table.row is an array of strings, so everything's getting converted to a string for it to get displayed, pulling in all those fields. And then by the end of this little for loop, we have a full array of rows that we want in our table. And so we're going to create our new table. We're going to say that it has columns, and we're giving it the value of the columns that we've just defined with rows, and that's with all of the rows content. And then with focused, you can change, there's quite a few different little attributes that you can set. And I decided to give it the same height as however many tasks we have. And then we're gonna do default styles. So I'm gonna grab whatever the default styles are for the bubbles component. You can see here that we've modified the header. We've decided to give it a border. We wanna change the border foreground, and we change all of this stuff. So things in the lip gloss style that we decide to set and customize for ourselves. And then we set the styles for the table. So just a built-in function, okay? For the record, if you're looking to see what kind of capabilities there are in the APIs for these libraries, for any Go libraries, go to package.go.dev. That is the easiest way to see what exported functions are available for different libraries. And if the developers are kind enough to use GoDoc, then everything's all documented and there's examples and it's beautiful. And then finally, we've got the Kanban board. So I know some of you might have already seen the Kanban board tutorial. If you haven't, it's around. All right, I'll put it somewhere. This is going to allow us to do an interactive, kind of interactive. It's like a faux interactive experience. All right. But what's happening here is I'm going to grab all of the items that I want in each column, because each of them are their own lists. So I'm going to grab the tasks by status. I'm going to group the to-dos, the in progress, and the done. And here I'm going to create a new column, and I'm going to convert all of my tasks to just list items. Here we iterate through the tasks and just append it to a list of list.items. So we create new columns for the Kanban board, and then we do a new default board and we add in those columns. And then all we do is we do a t.new program, and the main model is just the board, and that's it. That's it. This is it. You could do the exact same thing with the table, I'm pretty sure. I haven't tried it, but I encourage you to try it because I don't want to, but you can because you're ambitious and you're watching this video and you're learning. So I'm going to give you some more stuff to do. Don't let me down. And then here you can see init. So this is basically just the setup for Cobra. So here's where I'm defining all of those flags and the types. So this string P here allows you to do a shorthand letter. It'll also say in the help doc what each of these descriptions are for the flags. So that's really helpful. And then what I'm basically doing here is I'm saying the add command, list command, update command, delete command, Kanban, those are all subcommands of the root command. If I wanted to add a subcommand of the update, I would basically do this exact same thing, but it would be update command dot add command and then whatever the new subcommand is. You got me? You feel me? That's the whole thing, I think. Where am I? I hope you enjoyed this video. Let me know what you think about the format. I think this is a little more focused than when I'm trying to type along. By all means, if you prefer the videos where I code along with you, let me know. But I think I would rather encourage you to try and solve each of these steps. We'll see you in the next one. I hope you enjoy this project. I hope you enjoy all the little tasks I've given you along the way, a little sprinkled in there. I will pluck those little tasks out and I will add them to the description maybe. I'm sure some of you are gonna come up with some killer ideas for ways that we can improve this further. So I'm really excited to see what the forks bring, okay? Faith in the forks. Okay, yeah, bye. Bunny out. See you next time. Bye.